Hi, everyone. Welcome to our webinar, How to Get More from Your RTK GNSS. I'm Christine Grail with Leica Geosystems, part of Hexagon, and I'll be your moderator for today's session. Our presenter today is Burke Asay. Burke has more than 20 years of experience working with surveying technology. He began his career as a surveying technologist for the Nantucket Surveyors in Massachusetts, where he developed his appreciation for fast, dependable, and accurate hardware and software. From there, he applied his field knowledge to developing System 1200 applications with the Leica North American software development team in Montreal. He spent nearly 13 years supporting surveyors and engineers as an application and technical support specialist for spatial technologies and Leica Geosystems before moving into his current role as product manager for surveying and engineering in the US and Canada. Burke has a diploma in geomatics from the British Columbia Institute of Technology. Also on the line with us today behind the scenes is Pierre Labbé, our senior support engineer for geomatics. He will be answering your questions during Burke's presentation and will also assist with the Q&A at the end of the session. If at any time you'd like to ask a question, please enter it in the questions box, which you should see on your screen. If we're unable to answer all the questions in our live session, someone will reach out to you after the webinar by email. I do want to clarify up front that while this session is going to touch on GNSS modernization, it's not intended to be an in-depth tutorial on that subject. We will provide some additional resources in our follow-up communications in case you want to dive into that topic more in depth. As a matter of fact, we've loaded some handouts into that handout section of your webinar screen, so you can download those whenever you get a chance. What we do want to focus on today is the rover technology you use every day in your work and some advances you might not be aware of that can help you be more effective and more productive in your projects. We also want you to be aware of what's possible in terms of capabilities, so you can be more informed as you look to make future technology investments. I do want to mention that we'll be having an exit survey at the end of today's session, and we would love to hear from you on what topics you would like us to cover, both in upcoming webinars and in videos that you would like to see from Leica Geosystems. So please do take a moment at the end of the session when you exit out today to fill out that questionnaire, that survey. That would be a tremendous help to us, and hopefully it will help you as well. Now, we do have a quick poll that I'd like to share before we dive in today, and it's just one question here. And that question is, how often do you update your surveying equipment, firmware, and software? And if you could just take a quick second to answer that, that'll give us a good understanding of where everyone in the audience is today. And you can also kind of hold yourself up to your peers here and see where you're at. Give everybody just a second to enter their answer on that. All right, it looks like we've got about 50%. That's about what I would have estimated. So I'm going to close that out and share the results. So hopefully you can see what's on the screen there. It looks like 50% of you make that part of your standard operating procedures, which is excellent. And some of what you'll hear from Burke today is why that is so important. So with that, I am going to go ahead and turn it over to Burke. And Burke, you can take it away whenever you are ready.
Okay, hopefully everybody can see my screen here now.
Yes.
Perfect. Well, thanks so much for the introduction, Christy. What we're going to look at here today is just going to do a kind of a brief overview on the space segment modernization and kind of see the changes that have happened over the last, 10 or so years and kind of see where we're currently sitting. And then we're going to look at some kind of efficiency improvements that we've gained or been able to gain through improvements with the GNSS RTK systems that we currently have in place, but also with some services as well. All right. So with space segment modernization, we're really just going to look at the global systems. We're going to take a look at the 4 global systems and kind of see where we're at now and kind of see where we're headed, but also see where we came from and kind of see how that impacted a lot of the changes that we've made with Leica Geosystems, but also all other manufacturers with working with the current state of affairs with the GNSS constellations. So the first constellation we're going to look at is GPS, Navstar GPS. And this is really the oldest constellation available to us, kind of developed by the US government, and has been available kind of in use since 1983, but has really been full operational capacity since 95. It's been going through a number of kind of slow and steady modernizations over the last 20 years or so. And as you can see from the table here, there has been a swap out or the steady replacement of Block 2RR satellites, kind of starting kind of in the earlier 2000s. And we've seen more and more of the more modern 2RMs and Block 2Fs, and then working on the Block 3 satellites being brought into service. The number of operational satellites has not changed over time. The full operational capacity of the GPS system is 31 satellites, but we're seeing more and more Block 3 satellites coming online, and with that we see additional benefits. And those benefits are really the addition of additional broadcast signals. So the Block 2RM sats really brought in the availability of the L2C signal, and the L2C signal it's a stronger signal that can be beneficial in measuring and removing ionospheric delay, and that's really a benefit on the RTK side. And with that, we've also seen additional satellites be brought out, the Block 2F and the Block 3 satellites. So with the Block 2F, includes the L2C signal, but also includes the L5. And as hopefully most are aware, this does improve also the ionosphere correction, but also signal accuracy has been shown to be beneficial in canopy penetration and higher multipath environments when working with RTK. Finally, the Block 3 satellites, they add L1C. That's the for civilian GPS signal. And this is going to allow interoperability with Galileo and Beidou systems, as they will also broadcast a similar signal and will allow these constellations to work together and be easier to use on the RTK side for most users. Okay. As these newer blocks of satellites become available, these newer signals will be available on a larger and larger percentage of the constellation. And what you can see here is at L2C, it's going to be probably expected on all satellites. Again, it's expected around 2026. We're looking at L5, so a all 2F or Block 3 satellites by 2030, and then expected on all satellites in the constellation for the L1C and the Block 3 satellites by 2034. Again, these are rough estimates, and things do slide around a fair bit and have a tendency to fall behind, but there is a slow and steady movement to add more and more of these modern signals that provide a lot of benefit in standard RTK positioning. Then we get on to GLONASS, which is the second oldest of the systems. GLONASS has been kind of around since 1982, but kind of declared fully operational in 1993. GLONASS has been really less active in replacing legacy systems with modern satellites, and they're kind of lagging behind the other three constellations. But there are some scheduled launches that were shown in the news that will be bringing in kind of some newer K1 and K2 satellites coming in in 2026. So hopefully that will happen and allow us with some new signals as well. Okay. What's happening with GLONASS is that we're starting to see the K2 hopefully ready to launch in kind of 2026 and coming in the future. And with that, we'll see some additional benefits with the L10C and L20C. And then additionally, there's a modified K satellite that will allow us to be able to bring in an L5 signal in GLONASS as well. And again, the nice part about these modern satellites is that they're moving away from the FDMA signal structure and coming to a CDMA, which is more standard with most of the other GNSS constellations. And it's going to allow for no GLONASS bias, which is very nice. We're going to be able to move away from the GLONASS bias issues that we've seen in the past. And there's going to be better interoperability between the other GNSS constellations and provide a better tracking for our devices. Again, L5, what we see with most L5 signals, it's going to benefit longer RTK baselines and also multipath environments. But they won't be available for a number of years. Okay, so Galileo, moving on to Galileo, which is the third system here, is a far younger system than the other two systems. And because of this fact, it's planned as a modern constellation, with the first test satellite launched in about 2005. then having 8 launches of satellites between 2015 and 2018 to get up to the full operational capability. There are 4 IOV in-orbit validation satellites and 20 operational FOC satellites that are currently available. There was news that there's going to be some time between 2024 and 26 to add additional satellites to the constellation. Again, those would just be spares. And really the big thing and the good thing about Galileo is that the optimization of the constellation design and availability of spare satellites provides redundancy that really allows end user redundancy. So if there are loss of satellites, then they're still operational. But it also provides really good coverage at all latitudes. So even in the extreme latitudes, we do get coverage with Galileo. And we see here, Galileo has a modern signal structure, and the constellation is very beneficial for general RTK surveying. So similar to the quality of the GPS constellation and markedly better than GLONASS. the E1 signal is similar to the GPS L1, and the E5A is similar to L5. And provides kind of similar RTK performance for these constellations. Again, AltBach is a derived signal from E5A and E5B and provides multipath suppression. And the one thing that is really interesting about Galileo, and this is an interesting thing to note, is E6, which is not available for RTK, but it does include this new service, a high accuracy service signal. And this high accuracy service signal will provide a PPP correction for the Galileo signals, but also for GPS L1, L2, and L5, and be free of charge for end users. So this is a very interesting development. Again, it doesn't have, current testing doesn't show it having the RTK accuracy like some consumer-based precise point positioning services, like our sister companies, TerraStar, but testing accuracies of 30 centimeters in 2D and 40 centimeters in 1D are being seen, and those do get better over kind of longer convergence times. So it does, it is an interesting new improvement that will be available as we start to move forward. I believe it's supposed to become available sometime in 2024, which is later this year. How that gets implemented into existing hardware will be done through firmware updates. So that is something about keeping gear up to date. Yeah. Okay. BeiDou is the fourth kind of global GNSS constellation, and it was kind of developed over 3 phases. Phase 2 of the constellation became fully operational in 2012, and it just was available as a regional system, so just over China. But phase 3 of the constellation did a lot for us here in North America. So becoming fully operational in 2020, and it included a large number of these mid-Earth orbit or medium Earth orbit satellites. So they launched 26 at the time, and I believe there's 29 available now. And these do provide a tremendous amount of, well, they provide complete global coverage for us. So BeiDou is now since 2020, a very capable constellation to allow us to add benefit to everyday working environments in the US and Canada or anywhere in North America. And really does provide, probably 5 to 8 usable satellites with coverage over North America at kind of any given time. Right? So it is something that has happened in the last couple of years to really allow us to be able to have a full another additional constellation in the US and Canada. Right? So there are a couple of different signals between the 2 different phases. So BDS2 satellites have B1I, B2I, B2B, and B3I, and they're set up a little bit differently, but really similar to the Galileo GPS constellation, the BeiDou satellites provide a general improvement in kind of all RTK performance. So they are, if they are available to an RTK user, they will provide an improvement in their RTK position. So where does that kind of leave us here? It's really an overview as where we're kind of sitting. We've gone from probably 15 years ago, in 2008, less than 60 usable satellites, and we've really seen that drive forward over kind of the early 2020s here to allow us to be able to have, around 120 or 120 plus usable satellites. That includes kind of the regional systems like NAVIC and QZSS, but we have probably 110 satellites that we could use in North America at any one time as they pass overhead. So we do have a lot of more availability for satellites for use with RTK at this time, right? It's been a big change since 2009, 2010. Right? From a practical standpoint, what does it mean to the end user with equipment out in the field? It really just means, like I just did a couple of satellite availability reports, and we can see anywhere from, say, up to 30 kind of plus satellites available to us to RTK positioning at any one time, right? And this is very beneficial because it allows us to kind of start to do things and work in areas that we haven't been able to work in before, say 10 or so years ago. But it also allows us to be able to be more aggressive with what we do inside of our software to be able to pull out and use the best satellites available. All right. So when we'll talk about RTK hardware, so that was a little background on the constellations and where they are now. But when we talk about hardware, it's really about talking about what we can do with the efficiencies inside these hardware to be able to make us the most efficient out in the field. So when we talk about GNSS RTK system, what does it really consist of? And what we're talking about here is a GNSS antenna, an antenna of some sort to get the signal, a measurement of some sort to develop a position from those signals, hardware, so how things are put together, but also additional features or options that might be available inside of the hardware. And then a big one that's kind of shown here in green and blue is the RTK processing kernel, which is how we take our correction information, our position, to be able to determine a precise position out in the field. And then also the RTK corrections that we can receive into our system to be able to develop that position. Okay, so that's what we're looking at as a GNSS RTK system. We'll look at that slowly, how things have progressed over time, but also how more recent improvements have allowed us to be more efficient out in the field. So everything with these GNSS systems really start with a good quality antenna, right? So no matter the manufacturer, a quality antenna ensures, the ability to track signals, right? And ability to track, weak signals and being able to use those as we need them, okay? And if you're tracking good signals, it's one of the things, if you start with a good signal, if you're being able to track things well, we do have right off the bat, chance of wrong position is greatly reduced. So we want to be able to start off with good information, right? Then we look at the measurement engine, and the measurement engine is really for acquisition speed and being able, signal sensitivity, multipath mitigation, taking the signals that are there and developing a position from them, right? So again, as well as with the antenna, starting with good information, we really have fewer and fewer chances of wrong positions being produced. And it's the less wrong positions that you have, the more reliability that you have, the more efficient you're going to be, because you're not having to worry about any type of wrong information or wrong positions being developed. Okay. But the other thing that we really have to worry about here is future proofing. With a measurement engine, there's certain restrictions. And one of them is really having enough channels to allow for growth in the constellation. And again, there's not a huge amount of more growth in the constellations that we're going to be seeing. But if we look at our practical example here of what's available for GNSS positioning right now, what we have is we have kind of 30 plus trackable satellites in an open sky environment. And if we look at the signals that we kind of track, we'll just throw it out there, about 4 signals per satellite, maybe 4 or 5, depending if we have some L-band stuff or things like that. But we look at probably 136 signals, which if we look at our current GS18T or any the GS16 with the current OEM 7 board, we get 555 channels. So we're definitely able to track everything inside of our needs, right? So it's future-proof. This current GS18T will be able to handle any of the additional channels that might come up. Doesn't appear to be that many more being developed in the future, but things might happen, but it will be able to handle them, okay? Whereas if you look at kind of some of our legacy stuff, it's really teetering on the edge, and it might have some deficiencies, not deficiencies so much, but limitations with how they were developed. So there was 120 channels on the GS14 board, And again, that's where we start to run into some issues with, running out of being able to track all the satellites available to us. Okay. And coming back to our GNSS constellation overview, you'll see Leica Viva did come up, and it came up about 2009 to 2016 was when the GS14, GS15s, the first OEM boards were being used, and there wasn't the need for that many satellite signals when we kind of came into the start. But as it progressed, we came forward with the GS18 and the GS16 boards, and we are able to now cover everything that's required, right? So again, there might be some limitations with some legacy boards, but again, that is just on tracking satellites. They're still functional, but there might be some limitations with tracking kind of more modern signals like L5 or B2 or E5A, right? But one thing to be aware of is that there's no real major changes to GNSS constellations past 2023 kind of planned. Like most of the planning has already been done, so we know what's happening, and that's where we can be fairly confident that the current boards are good, they're solid, they are very high quality hardware inside of our current equipment anyway. Yeah. So with that being said, looking for a quality antenna, looking for a quality measurement engine, but then also on the hardware side, it's like, how is it put together? And again, with efficiency, a lot of time efficiency comes down to downtime, right? So being sure that equipment being put together is going to survive the issues that happen out in the field. Again, it's about making sure that it's IP rated, mil-spec rated, making sure modern communication devices, you're able to communicate with everything that you need, and making sure that equipment survives because it's well put together, right? But what also to look at here is kind of the physical limitations of GNSS hardware technology, right? So the ME, the antenna, they're getting close to the limit of what will be possible given the limitations of the space segment. There's not going to be any huge improvements in the ME or the antenna. So what we have seen over time has been seen that adding additional sensors, or doing terminology sensor fusion, or adding additional sensors into a system allows us to be able to add those efficiency gains that we didn't see in other systems. And again, that's been proven out with the IMU tilt with the GS18T and the I, and visual positioning with the GS18I. And we can see that with the testing, like 30-second static testing measurements, straight out to instantaneous measurements. The accuracy is the same, but we have a dramatic reduction in time taken or needed to take a point. And that's the type of efficiency gains that we'll probably see moving forward, right? We've seen them now with the GS18T. We've seen those efficiency gains by adding in additional sensors and using sensors with software in better ways to kind of group things together and being able to allow us to be more efficient in that way, right? So there's probably not going to be huge gains on the hardware aspect or just the tracking or acquisition of signal from the antenna or the ME, but we'll see improvements from the hardware aspect with additional sensors like the GS18T and I. But also on kind of a software side. And again, we've moved on to this RTK processing kernel. The RTK processing kernel is an application that runs on board of the system. It's tied in with the operating system that allows it to take RTK correction information, the position provided from the measurement engine, the signals available there, and be able to process your RTK position. And here's where we've seen major improvements because we've been given additional signals. Because we have L5, because we have E5A and E5B, because we have these additional signals, we're able to then use these with the additional satellites that are available to develop new and innovative ways to work with this data to be able to ensure, again, number one, the most reliable position available to provide, but also a more availability in harsher conditions, right? So we want that reliability there so that we're able to be as sure of that position as we can, but we also want the availability there so we can work in harder conditions, right? There's a lot that's been done over the last couple of years, okay? And that brings me to the RTK Kernel Improvements Initiative that started up a few years ago. And that really comes back all the way back to May 2021, where we had some improved GNSS signal tracking by implementing something called multipath reduction and interference mitigation. There were a couple of options available on our latest version of OEM boards. The GS16, GS18 is where those were available, and these provided. I'll run through the improvements they provided. Then we jumped into some RTK positioning, phase 1 and phase 2, that provided some additional improvements under difficult conditions. And we'll get into some numbers here, kind of look at those. But first off was the improved GNSS signal tracking. So this is code multipath reduction. So this was an option that came in. And what it did was, it was some software. It was, again, working with the existing hardware, but software improvements that allowed us to be able to cut down multipath quite dramatically in kind of medium to hard conditions. And what you'll see is, you'll see a test environment, and you'll see the multipath without the multipath reduction, and then you'll see the multipath reduction shown here where it's been cleaned up significantly. And you'll see that also on the left-hand side, without multipath reduction, with multipath reduction, the differences there inside of that graph. Okay, so it really is about trying to improve incoming signal so that it's easier for the RTK kernel to be able to use that and then develop an RTK position and produce and lessen wrong fixes. Okay. What we also have, what came out was interference mitigation. What interference mitigation was the working on improving signal quality when there was other interference or other radio signals in the area, right? So it's increasing tracking sensitivity, but also cleaning up those GNSS signals. You have a GNSS signal from miles and miles and miles up, and you have something else broadcasting nearby. What ends up happening is those signals can be washed out, right? Adding in these notch filters inside of the system allows us to be able to extract those signals and use those signals in our RTK positioning. And it really does allow us to be able to work better in those types of difficult conditions, right? And what you'll see with this graph on the right is, you'll see on the bottom, you'll see some hopping, some frequency interference there, and then you have the no interference, and then you'll see the mitigated solution as that green line, and how close it got, again, in removing that interference. And again, these are software options that are available for kind of the current OEM 7 boards that allow us to be able to work in harder conditions in areas, and also future-proofing against situations that might come up in the future with kind of additional frequency usage, terrestrial frequency usage, like Legato or Light Squared, or those type of near band frequency usage for GNSS. Okay. This kind of working together was called HDR surveying. It was put out in the paper that will be made available as part of the downloads. But this multipath reduction, interference mitigation used together really allows us to be able to provide a better solution, right? Really provide a better solution. You'll notice here on the in the blue and the red, blue is with HDR off and red is with HDR on. And you'll notice that the 3D error gets minimized when using these things together, using the multipath reduction and interference mitigation together to kind of clean up the signal, but also be able to clean up the signal for use with the RTK kernel. Okay. All right, and that moves us on to the RTK positioning phase 1 and 2 that happened through development. So what we have is, we have some test environments here. So again, this is just kind of a look in where testing was done. So there was testing done in normal conditions, medium challenging conditions, and also some difficult conditions. And they ended up kind of merging all that data together. And this is kind of the Hairbrook test site, but testing was also done in other parts of the world. And what we kind of run into here is, we run into the results that happen in changes from firmware to firmware. Okay, so again, this is going back to the initial testing that was done from the jump from 7 to 7.5. There were additional improvements as well, but most of them were done on different baseline lengths. So the initial jump from 7.3 to 7.5 was done on kind of mid-length baseline lengths for network environments. And what we saw in these type of environments is, we saw the availability of getting a fixed position in kind of medium and difficult environments to go up dramatically. So 14.6% for a medium environment and 27% in a difficult environment. Okay, and when we saw that by using this different structure and augmenting this RTK processing application to manage this data, we also saw the error drop. So we were able to measure more points and get fixed in more locations, but we're also, and the most important part, our error is the same or better, right, as it was from previous versions of the RTK kernel and the firmware, right? And if we look at that in kind of in more depth, our reliability in all cases went up. So in all cases, the 3D CQ and the reliability metrics all went up. And also the reliability of the fixed position also all went up. Okay, so 703 to 7.5 improvements with all of the reliability metrics. Sorry. And what we saw, and this is just a overview on the dense canopy itself. With the dense canopy itself, we did struggle with version 7 or kind of older versions because we really wanted to focus on reliability and we weren't managing with the ability of these additional signals. What it's allowed us to do is manage this better and be able to provide much better availability in these denser environments. So you'll see a 66% improvement from version 7 to version 7.5 in these harsher environments, right? So it's just allowed us to go up to about 78, 80% in these harsher environments and still remain reliable and accurate, like we would, which is our number one driving factor. Another thing that did kind of come about because of this was the ability to kind of lower fixing times. So time to fix statistics under a dense canopy was improved dramatically. So we went from about 46.2 seconds average down to about 15 seconds. So about a 31-second improvement between the version 7 and version 7.5, but again, remaining that same reliability metric. We're able to fix faster and be more accurate. And again, just dense canopy, more numbers here with dense canopy, but you're able to see all of the measurements that were taken, all with inside of standard RTK ranges, and the comparison between 7.5 and 7.5 for kind of standard here tilt compensation RTK under dense canopy. So there are some mass improvements there working inside of difficult environments, and those are all kind of been able to be brought about by having the access to these modern signals that are coming from the GNSS constellations, but also improvements that will continue to happen as we move forward, right? Most of all of these improvements are going to be continually be added, and getting the most efficiency out of your current like equipment anyway, staying up to date with your firmware is going to allow you to be able to work in more difficult environments, have additional and more reliable results, and will allow you to be able to kind of do things that you weren't able to do in the past with outdated, with older measurement engines, or sorry, older RTK kernels. So these improvements are moving forward. Again, they're constantly, the GS team is constantly improving, and they're constantly trying to provide the best position available. And that really comes down to what we see today. Again, this is only a comparison to the Leica equipment that we have and what we're seeing. But the red kind of 20 years ago with the System 500, then we have the black with the 1200, we have the green with the Viva, and then the Viva XRTK, and then we have the Captivate coming in, and then we have here the latest RTK kernel improvements that allow us to work in more and more complex environments and get more and more availability. Again, it'll be very tough to be 100% across the top, but we're working towards, or trying to work towards, providing the most efficiency there for working in the harshest environments possible. Okay. So about pushing the boundaries there. Okay. So what does each component do? We get back to the RTK corrections. So again, when it comes to RTK corrections, the RTK kernel, they work hand in hand and they work side by side, right? So there's always a need for corrections. And when you're looking at corrections, like where are they coming from? So again, a lot of our users still use local bases. There's a lot of white spots in North America when it comes to network coverage or cellular phone coverage. And in those type of situations, what we do need to have is we need to have, if you want to get the most efficiency and performance out of your GNSS equipment, having a full constellation on both the base and the rover is very important. But also, we're looking at tracking 30 plus satellites. Having high over-the-air speeds for any type of UHF radio traffic is also important. So making sure that you're able to get into situations where you can have equipment that can be matched up and give you the highest over-the-air speeds possible, be able to take the information and pass it from the base and rover as efficiently as possible. Because as more and more signals come in and we track more and more satellites, those packages get bigger and bigger, and the faster you can get that data over the air, the better your device will perform. Another major efficiency is the ability of local networks. And again, with Leica, we have access to the Hexagon SmartNet global network, but also the local one. Here we'll see the global, and we'll also go in and see the local US and Canada. And they're also have been working through modernization. So the modernization of reference sensors. So SmartNet North America, they have now a full constellation tracking. So they've been working on improving or updating legacy reference station receivers, and more than 95% of the network is running full constellation, and most of the units that are not full constellation are in remote areas. So they shouldn't affect major urban areas or major areas of work on the eastern seaboard or west coast. So these are available, okay? And they're constantly adding stations into white areas. So in 2023, there was 160 sites that were added. In 2024, anticipated 100 to 130 sites. And they're constantly adding in sites to kind of add in a little bit more area. And you can see that now with even the map improvements. So you'll see some wider spacing sites here. But if we were to go back to the global site that hasn't updated yet, there's no coverage shown there. So these coverages have added additional value to making you more efficient, being able to go out to areas that you weren't able to work in the network before, but now you'll be able to get those with full constellation. Okay. But there are places where network RTK solutions are not always available. And we do have other options that a lot of people aren't aware of to be able to provide correction data to make you more efficient in areas where you might be in and out of network or out of network altogether. Those solutions are, I mentioned it before, there's a PPP solution partner that we have, and we work with providing called a SmartLight Global solution, and be able to provide a PPP solution available throughout our software and systems. And these, in North America, we have 2 satellites that do provide PPP solutions or PPP correction information to North America, so 9AW and AORW. And these do provide kind of RTK style positioning with a convergence time. We'll just kind of walk through that quickly. Okay. So these PPP services, which I mentioned them earlier, the HAS system that's going to be coming from Galileo, what they end up doing is they allow certain functionality or RTK style, kind of centimeter level accuracy in the best conditions when you're outside of a network, okay? So with the SmartNet Global system, it does provide RTK bridging. So RTK bridging allows us to be able to work inside of a network, but then as soon as you work outside of a network or you lose connectivity from the L-band satellite, what's new here is it does kind of, last year and a half, it allows us to be able to tie into an internet connection, okay? And again, activation time is a lot quicker now, but internet connection available when you're outside of or lose connectivity with the L-band satellite. Secondly, with PPP, so what's kind of newer, again, the last couple of years, internet connection coming from SmartNet Global. It allows us to be able to get L-band corrections directly from the internet, so you don't need to track the L-band satellites. So if you're in an area of not good south-facing coverage, you'll be able to use it with the internet. And again, conversion time is lessened quite dramatically. So again, it was kind of over 20 minutes before, now it's 10 minutes or less. Typical conversion time is probably in the 5-minute or less range, but it does allow us quicker convergence times when using PPP outside of a network area. And a few other things to make it easier inside of our software, to make it more efficient and make it more streamlined, is the ability to use a custom adjustment. Again, velocity mapping and stuff is available, so there are some reference frames that are used, but using custom adjustments allows you to be able to tie into your reference network as quickly as possible. But just measuring a couple of points. Here's the major updates here. What we see is we see quicker convergence times. Delivery method is now available in mobile internet, so it really does allow us to kind of use it wherever we'd like to have it. And it allows us to get that type of PPP accuracy of like 2.5 centimeters to 5 centimeters in vertical accuracy, where we can still remain efficient getting that type of data in the field without having to kind of go back and get a standalone base or look at other options to be able to do RTK surveying in the field. Okay. Again, this service here, as it is with the faster convergence times, is just available on the newer boards. So the legacy boards are still able to use the PPP service, but it's not the faster convergence time, but it is available. Okay. And how does it work? Again, just a quick little overview here. We have network RTK coming from inside the system. If we move outside, we no longer have internet. We can get it geostationary and consider bridging inside the network with L-band. If we move outside of the network, more than 10 minutes, we'll start to get a PPP solution with the L-band solution. If we move back into internet and we lose geostationary satellite coverage, we can get it from the internet. And then if we were to move back into the network, we'd just go back to the network coverage. Okay. And what this really does is it allows us to have the type of coverage that we'd like, right? So we can have full coverage in North America, or SmartNet Plus here is the standard network RTK coverage, which is in green. Then the SmartNet PPP allows us to be able to kind of get anywhere in North America. And then the using of the both systems at the same time allows us to get slightly more accurate with regional network RTK, but also allows us to work in kind of standard RTK type accuracy using the PPP solution in other parts of or other areas where there are white spots inside the network. So that not having to set up a base or not having to do additional things allows us to be able to stay efficient in the field and allows us some redundancy there as well. Okay. So that's really all I had kind of laid out for us today. Hopefully I stayed inside the timeline, but hopefully you're able to get something from that. Perfect, thank you.
Thank you, Burke. I appreciate that. Wow, there is a lot going on with RTK GNSS. There's a lot to stay on top of. So hopefully this has been helpful to those in the audience. We did have a number of questions come through, so I do want to get to those. Again, as you, when you do leave the webinar today, please do fill out that exit survey and give us your feedback on what you would like to hear from us, because we want to make sure that we're keeping you up to date on all the latest information and things that you need to stay as productive and efficient as possible. One of the questions that we have here, and you might have touched on it, but I want to make sure that we address it, is how will our equipment track the few legacy satellites once the P code goes away?
Oh, I can't see that one. Once P code goes away?
Yes, once the P code goes away, how will our equipment track the legacy satellites once the P code goes away?
Well, I don't believe there'll be any difference with tracking kind of standard tracking. I'd have to maybe bounce that back off the GS team in Hairbrook to kind of be able to clarify on that answer. But what I'll do is we'll clarify that answer and bring it back to you on which P code you're referring to. Right?
Okay, excellent. And then this is a great question, actually, and I think this goes back to the interference mitigation. But a few years ago, there was that situation, quite a few years ago, actually, there was that situation with Light Squared at the time was the name of the company, and there was all this this discussion about how are we going to protect the GNSS with all of the new networks coming online and everyone wanting to take that L-band capability. Is that where the interference mitigation upgrades come into play?
Yeah,
Will
so
it protect
interference
against?
mitigation will work with that. So what will end up happening is that we're able to kind of using filters, using electronic filters, filter out any of that type of interference. So there's no fear in losing availability of satellites because of interference or kind of terrestrial interference. We have that mostly covered with an interference mitigation that would affect kind of that light square to legato frequency range.
Okay, yeah, because certainly there's a lot of demand for the network. Faster and faster is what everyone wants, right? So I'm sure there's going to continue to be more things coming along, even though that particular issue was resolved. I'm sure there's going to be more in the future. So it's good to know that we've got people working behind the scenes to make sure that that's not going to be a problem. We've got a number of questions here, just trying to go through and pick the best ones. Pierre, is there something that you feel it would be especially helpful for Burke to address? We've got a lot more coming in here, and I want to make sure that we get the best ones.
Yeah, there's one. It says, I think there's a paper on it, but one question is, how is Hexagon preparing for the 2025 solar maximum?
So there's always developments in the background looking to add performance improvements because of ionospheric interference. And again, some of the improvements have already been brought into place with the current RTK kernel, but they're always working. The GS team is always working on adding additional improvements. And again, they don't let us know on those improvements directly ahead of time, but I know they are working on being able to provide the best quality positioning available, and the ionospheric activity is a concern, and they're working on being able to add the best positioning possible with that in mind. I don't know when any type of improvement like that will be available, but that is top of mind. Yeah.
There's someone here who has a great question about they're running Captivate 8.0. Do they need to check to make sure that multipath reduction and interference mitigation is giving them the most optimal performance, or is that kind of built in to 8.0?
It is a setting inside of Captivate to be able to add or check on those options. So you should check. So we do recommend multipath reduction being on and interference mitigation on if that's available to you. We are working towards, again, with any type of improvement that is made, they'll bring it in as an improvement, but allow users to be able to turn it on and off and see the performance they were seeing before without forcing individuals into neuroprocessing techniques. So because of this interference mitigation, multipath reduction, our newer techniques, they are available as an option inside the software. Yeah. So there's just a checkbox. And we do recommend them locally to have them on. We do see a major benefit in them being on. Yeah.
Okay, the focus of the webinar at the outset was on upgrading firmware to take advantage of a lot of these capabilities. And we have someone who wanted to know, with older generation GNSS units that are limited to 120 channels, is it typically L5 and new signals that are not being tracked, or can you comment on how the software optimizes this? Are they able to upgrade to take advantage of those performance capabilities?
So the older or the legacy OEM 617 boards that are available in the GS14 and the like, yeah, it's L5. They do track beta, some signals, so they track B1, but they don't track B2. So there are certain signals that aren't being able to be tracked by that ME, and so that would be where a newer board would allow you to be able to get the best performance available. But and I probably didn't say this enough, the improvements that do happen, so the RTK kernel improvements, they do affect those legacy instruments as well, right? Not probably to the same degree as the newer hardware, but they do provide a net positive effect for the legacy equipment as well.
Okay. We have a question here about the post-processing calculations. Is there a benefit of applying some post-processing calculations a few days later on RTK positions taken in a difficult environment to account for better known satellite positions once they're tracked rather than the broadcasting position?
There could be benefit. Again, you'd have to be storing raw data, and in some situations, users aren't storing static data or raw data while they're working. So there could be benefit in that, but at least as a redundant observation. But you would have to have the equipment set up to be storing raw data. Yeah.
And there's a comment from Wendy about SmartNet. That
Okay.
SmartNet is densifying network to help with ionospheric.
Perfect. So as part of the network improvements, Wendy added is the network or SmartNet itself to aid in all RTK, not just like RTK. The network is improving by adding in densification or densifying the network for use.
When let's see, when someone wants to make sure that they're keeping their firmware up to date, maybe they've decided that it's best practice to update their firmware as part of their standard operating procedure. What's the easiest way for them to do that?
Say that again, Christy.
If someone wants to make sure that they're updating their firmware on a regular basis as part of their standard operating procedure, what would be the best way for them to do that? Is there an easy way to make that just part of their SOPs?
Yeah, well, being able to set up the standard to upgrade is always good. Like doing it a couple of times a year is what we see a number of companies do. Again, we know it is a little bit of it takes a little bit of time to do that for especially for larger amounts of gear. But it is recommended to try and stay as current as possible because you do get those benefits. And reaching out to local support or a local sales rep to be able to find out the best way or give advice on how to best manage the upgrade process would be the recommendation.
And how do people know when new updates are available? Is that just sent out? I would imagine that someone with a customer care package, for example, would get those notifications. Is that the best way for them to stay informed?
There's a couple of different ways that our users are informed. So on the controller themselves, there will be, if it's connected to the internet, they will be informed that there's new software available. There are some emailing and mail groups that do force out information on new firmware, but also being inside of My World. Being inside of My World is where you get the most amount of information and pushed you regarding these type of improvements.
Okay, and CCPs help with that as well too, correct?
Say that one more time, sorry?
If CCPs help with that, I mean, if you have a CCP, then you are getting the most current information and updates.
If you have a CCP or a current CCP, what you can do is you can load any of the latest versions of the firmware and software. So yeah, keeping your CCP up to date does allow you to be able to take advantage of these new improvements that happen continually.
Okay, here's a great question. What role do you see AI playing with GNSS? Or the artificial intelligence discussion comes into play everywhere, I think.
Well, the smarter and smarter systems become, the smarter and smarter data can be used. So over time, AI will be implemented into these type of processing kernels. But until that time, again, that's still a little bit of a ways out. But more and more of AI is going to be used not just for standard software, but for the backend as well. So it will happen eventually, but it'll be a development cycle for sure.
Well, and as I've noticed with AI, a lot of things in AI development tend to happen behind the scenes. So they might be more invisible and not so much public, like with the chat GPTs and everything. There's a lot going on with AI, even behind the scenes. So it'll be interesting.
There
Okay.
was a question on cutoff angle that I saw pop up. We recommend the standard 10-degree cutoff angle. Again, the system itself and the RTK measurement engine, the RTK kernel improvements, what they do is that they are constantly looking at signal and trying to determine if the signal is good or bad. If you're limiting cutoff angle, what will end up happening is you're limiting some satellites, and it's in our view. Would like it's better to have the system do that than for the end user to do that. It'll take in all of the information that it has and be able to say, okay, these are good or bad signals, and then drop off the ones it doesn't like. So we still recommend a 10-degree cutoff angle, but that is up to the user discretion.
Okay, great. There were a few people who noticed that you kind of have to turn on multipath reduction or have it available. Is there any reason not to have it on all the time?
We always provide the an option to turn it off, but it is one of those things that it was brought in as a feature, as an option, and it is something that locally we've asked for to be able to make it a default option to have it checked on all the time rather than a user have to add that. But at some point in the next number of firmwares, it'll end up being removed probably as an option and just always be available. But right now it is available. It's not a paid, it's a free option. And you shouldn't see any differences between working in the open sky environment and working in a high multipath environment by having it checked on and off. But the GS team over in Heerbrugg they always like to provide a redundancy there. So if you do see something happen, you can always check it off and verify your position.
Okay, and I think this question touches back on what we had discussed earlier, maybe, and they wanted to know about GPS spoofing becoming a problem. What is Leica doing to make its equipment spoof proof? Is this again with the interference mitigation?
That probably has to go for in-depth on that. We probably have to go back to the GS team. So what we'll probably end up doing is maybe making an answer sheet or answers these provided to end users that are interested in it. But that I'd have to kind of push back to the GS team in Heerbrugg.
Okay, perfect. And just to let everyone know, because we do have a number of questions here, we will not be able to address all of them today. So we will put together a list and make that available and certainly answer any of these questions behind the scenes that are not addressed today. Some of these are pretty specific, and I want to keep to the ones that are more broad-based.
There might be a good one. There's one about does the increased in number of tracked signals influence the use of a extra relay radio station used in RTK setup?
I'm not a radio expert, but from what it appears to be, it does. So the packaging of the signal, so the more and more signal you have, the bigger package it is kind of passing through the radio, and the it does appear to affect repeater setup or even an RTK, a base station, a radio connected directly to base. It does require faster over-the-air speeds to be able to handle that data. So when you say relay radio station, I'm guessing you mean a repeater, and I believe that would also be the case, yes. It has to receive the data and then send it out. And that's something that we're looking into is there's a few things coming out with RTCM developing a standardized radio setting option, and some of those things are going to be available fairly soon. With that, we want to be able to provide clarification on the best ways to be able to use radios and repeaters, because we see a lot of people going back to that. We're not going back to that, but using them in situations where, especially short baseline situations where they need really high vertical accuracy. So being able to provide that information straightforward to just say, these are the settings you need to be able to do the tasks that you do with these higher level of signals is something that we're working on putting together.
Okay, excellent. We are near the top of the hour here. I do have a quick video I'd like to share just as we wrap up these last few questions. So I'm going to go ahead and play that, and then we'll keep talking while the video plays. All right, and Burke, I'll need to ask you to unmute yourself when you speak, but you recently took, you wanted to test some of these capabilities. You wanted to see what the possibilities were with the receiver when you have all the latest firmware and software upgrades. So you took the receiver out. Tell us what your results were. What were you seeing?
No, we did a lot of testing with it in North America because we always like to validate the fact of what they see in Herbrook, and we saw dramatic improvements in areas with heavy tree cover, right? That was one of the things that was asked about, like heavy tree cover, where you work, and how far can we kind of push those limits. We've seen dramatic improvements with that, going from version 7 to 7.5. Again, 7 to 7.5 was for kind of standard network baselines, and then 7.5 to 8, they added in those same improvements for kind of shorter baselines. But what we really do see is we see the ability to work in kind of harder multipath environments and do it very seamlessly. So again, if you're looking to kind of push it into push your environment a little bit into more challenging environments, moving up in that firmware to get those benefits is important.
Okay, excellent. And the instrument that you were using here in this video, that was actually the GS18i, and you also took it out to a stockpile.
Yep.
Tell us what we're looking at here.
Yeah, so the GS18i, it's one of those ones that we talked about where Leica thinks the main improvements are going to really happen is with adding additional sensors and additional functionality into the hardware. And the GS18i is one of those pieces of equipment that allows us to use different sensors to do things that we weren't able to do in the past. And again, here we're just taking a shot of a very varied stockpile, just as an example, and been able to take that and use that information to develop volumes, right? And rather than measuring a whole bunch of points, we just walked around it, sent the data into the office, and was able to generate a volume. But there's a lot of different ways to use these newer pieces of equipment. And my recommendation is to, if you're wondering about them, reach out to your local sales rep or and ask them for some overviews on the hardware.
Yeah, so I would say that's really the key takeaway, whether you're looking to upgrade your technology capabilities, because obviously having the latest and greatest hardware is going to give you a lot of capabilities compared to the older hardware, or whether you're looking to get the most efficiency and productivity out of your existing hardware. Your best bet is really going to be to reach out to your rep or your dealer and talk to them and find out what you're missing, right? Because I think that's what we're finding in the industry, is that a lot of people just don't even realize what those capabilities are. Now, I'm seeing here that what you're doing with the data is actually sending it to GeoCloud Drive. Can you touch on that for just a minute?
Sure, yeah. It's like, I think what you said quickly there it's true. It's like there's so many changes that happen so fast that a lot of times we miss out on the changes that might be beneficial to us. And the point of these webinars is just to kind of bring up the things or the changes that are happening. And with GeoCloud Drive, it's another change that happened. It's an update to a file transfer service that we have that allows us to be able to transfer, but also store data online for use in collaboration between groups. And it's something that still a lot of people don't know about. And there's been a lot of updates to that, and it's been allows a lot of flexibility to the end user.
Okay, excellent. Well, again, please do reach out to your dealer or rep if you would like more information. You can also go to pure-surveying.com, and there's additional information there. This does bring us to the end of our session today. I know that we did have some questions that we were not able to address, and so we will reach out to you separately by email. We'll put together some Q&A and make sure that those are addressed. Thank you so much, Burke, for your time today. Thank you for those of you in the audience for staying with us. And please do provide our feedback provide your feedback so that we can continue to bring you useful webinars in the future.
Perfect. Thank you, Christy.